Okay, so now I'm going to be factoring trinomials. So factoring trinomials. Here's a trinomial, three terms, and I'd like to factor it. Well, to factor a trinomial, the very first thing you want to do, the first step, is to factor out the GCF. So the GCF for this trinomial is 2x. So I'm going to go ahead, I'm going to take the 2x, and I'm going to factor out 2x. Dividing each term by 2x gives me the trinomial 2x squared minus x minus 10. All right, so that's step one. Step one is to factor out the GCF. All right, now step two is to take this resulting trinomial that we have here in the parenthesis and go ahead and factor that. And we want to factor that using the FOIL method. So step two here, the second step in the process, is to take the resulting binomial here, the one in the parenthesis, and use the FOIL method to factor that. So we still have the factor of 2x. We're not going to drop that factor. That's still a monomial factor. But now, to use the FOIL method, what I'm doing is I'm looking at this trinomial and I'm assuming, since I've already taken out a binomial factor, that the only factors that would be left, or sorry, since I've already taken out a monomial factor, a single term factor, the only factors that would be left would be binomials. So that means FOIL will take me from those binomials to my trinomial. That implies that the first times the first would give me this term, f times f. So whatever goes here and here, when I multiply it, I should get this term. Also, it implies the L part, last times last, whatever goes here and here, should give me this, 10. The O and the I, that's what we check. Once we fix first, first, and last, last, we just check O and I to make sure it gives us the middle term. So let's go ahead and try with the first, first. We have to think about what we could possibly multiply together to get 2x squared. Remember, each one of these parentheses needs to have a variable in it. So in order to get 2x squared, multiplying first times first here, I'd have to multiply 2x and 1x, or x. Because to get 2x squared, this is all I can really do, 2x times 1x, because 2 is a prime number. Now, that fixes the first times first. These would have to be the two terms if I expect them to multiply to give me 2x squared. For L now, let's focus on L. For L, there are two possible choices. I'm either going to do a 1 and a 10, because 1 times 10 would give me 10, or I'm going to do a 2 and a 5, because 2 times 5 also gives me 10. Well, there's some things that we can use here. For instance, if I'm going to use the 1 and the 10, I wouldn't be able to put the 10 in this parenthesis here, because if I put a 10 in this position, the 10 has a common factor of 2 with the 2, and I'd be able to factor a 2 out. But I've already taken out the GCF. So when you're trying to place these numbers, make sure you don't put a number in a parenthesis with another number that has a common factor with it. So I couldn't put the 10 here. It would have to be the 1 here, which would mean the 10 would have to go here. And then let's try now to see if we can find outside, outside, inside, inside. Outside, outside would give me 20x, 2x times 10. And inside, inside would give me 1x. Is it possible to get negative x by either adding or subtracting 1x and 20x? I don't think so. So that means these will not work to give me outside, outside, inside, inside. Let's try the other pair. Let's now try the other pair of numbers. So instead of the 1 and the 10, let's try the 2 and the 5 instead. All right, let's try the 2 and the 5. So if we're going to try the 2 and the 5, the 2 can't go here because 2 and 2 have a common factor. It would have to be 5 here and 2 here. Now let's check. Let me see here. Outside, outside gives me 4x. 2x times 2. Inside, inside gives me 5x. 5 times x. Is it possible to get negative 1x from 5x and 4x either being added or subtracted? Why, yes, it is. If you subtract 5 and 4, you get 1. In particular, if you let the 5 be negative, 5x be negative, and 4x be positive, when you combine negative 5x and positive 4x, you indeed get negative x. So therefore, I would want this to be a minus sign so I can get my negative 5x, and this to be a plus sign so I can get my positive 4x. And there you have it. The factorization of that trinomial, well, we have a monomial factor, 2x, but we have two binomial factors, one 2x minus 5 and one x plus 2. So those are the two binomial factors, and there's the monomial factor. So this is the complete factorization of that original trinomial. All right? All right, now let's try another. Let's try this one, all right? Okay, for this one, we still have the two steps. Oops. We still have those two steps where we factor out the GCF first, but looking at these three numbers, there is no GCF bigger than 1. So the GCF is 1, so I don't have to factor that out. And I know that because 19 is prime. It only has factors 1 and 19. So factor out the GCF, check. We don't have to worry about that. GCF is 1. Step 2, use the FOIL method again. So let's look at one more example of the FOIL method, all right? Well, like I mentioned before, the F in FOIL will produce this term. The L in FOIL will produce this term here, and the O and the I in FOIL will produce this one. So all I have to do is look for two binomials for which, when I multiply the first term by the first term, I get 12x squared. And also, when I multiply the last term by the last term, I get 18. All right, well, there are many more choices this time. For instance, for first times first, we could have 1x and 12x. That's a distinct possibility. We could also have, let's see, not just 1 and 12, but we could also have 2x and 6x. And not only that, 12 also has factors, 12x squared also has factors 3x and 4x. So those are the factors of, those are some of the factors of 12x squared that could possibly be used in this binomial, all right? So we just need to choose a pair of factors. You can choose any pair you want to first. Like for instance, let's try the 2 and the 6. I think the 1 and the 12 are probably not right. So let's try the 2x and the 6x and see what works out. Well, if I'm going to try the 2x and the 6x, I have to try it with the factors of 18. Well, let's see, the factors of 18. The things that I can use to get 18 are 1 and 18 if I multiply them, 2 and 9 if I multiply them, and 3 and 6 if I multiply them. Let's see if any of these work. All right, so remember our goal here. So if I try the 1 and the 18, 18 would not be able to go in either one of these parentheses because 18 has a common factor with 2 and 18 has a common factor with 6. So 1 and 18 is automatically out. Let's try 2 and 9. Let me see. The 2 would not be able to go here because there's a common factor. So the 2 can't go here either because there's a common factor with 6. So 2 and 9 won't work because 2 can't go in either of those parentheses. All right, let's see. With the 3 and the 6, I can't put the 6 in either parenthesis either. 6 has a common factor with 2 and obviously with itself. So none of those work. So that means that none of these that I put with a 2x and a 6x, none of the factors of 18 will work. So I know 2x and 6x are out as possibilities. 2x and 6x are not out as possibilities. It couldn't possibly be those. Now, let's see. Still don't want to try the 1x and the 12x. Let's try the 3x and the 4x, all right? So once again, we could use the factors of 18, 1 and 18. Oops. 1 and 18. 1 and 18. We have 2 and 9 are factors of 18. And also 3 and 6 are factors of 18. So let's try these. Let's try this set with the 3x and the 4x. All right, let's go ahead and do that. All right, let's just copy these and bring them up to where we can see everything. All right, so this is what we're going to try now. We're going to try this 3x and 4x. We're going to try that with the factors of 18 here. So let's try 3x and 4x now. Let's see. We could use 3x and 4x for first. And then these are all the possibilities for last. Let's see if any of them work. All right, well, let's see. 1 and 18. If I put the 1 and the 18, well, 18 has common factors with 3 and 4. So 1 and 18 can't possibly work, actually. So it can't be 1 and 18. What about 2 and 9? If I use the 2 and the 9, the 2 would have to go here because the 9 cannot. And the 9 would have to go here because the 2 cannot. Now let's check for the outside, inside, the OI part of FOIL to see if these will work. Let me just move this out of the way a second here. Let's move this down a little bit. And let's check the O and the I to see if they work. All right? So I know that first will work. 3x times 4x will give 12x squared. I know that last will work because 2 times 9 is indeed 18. Now let's check outer. Well, that would give me a 27x. And inner, inside would be 8x. Now I have to consider, is there a way for me to get negative 19x by using an 8x and a 27x? Well, yes, I can get negative 19x if the 27 is negative and the 8 is positive. So that'll give me negative 27x plus 8x, which is negative 19x. So that means that I'd have to have a minus sign here to get the negative 27 and a plus sign here to get the positive 8. And here we have it. This is the factorization of my polynomial. The polynomial, these are the two factors. This would be the final answer right here. 3x plus 2 times 4x minus 9. And this is how you factor trinomials.